This is a piecewise function. We're asked to sketch the graph. So the graph changes behavior at x equals 1. It switches from this one to this one. So from the left, it's behaving like a straight line. Y equals 5x. So here's x equals 1. And if we have the line y equals 5x that has a y-intercept of 0, it has a slope of 5. So up 1, 2, 3, 4, 5, to the right 1. And then it's going to be a filled-in dot. It would be an open dot if it didn't have the equal to symbol down there. And so we're going to stop it once we get to that point though. So there's the graph of y equals 5x, and now we need to do the graph of 5 over x. And this graph usually goes on both sides of the y-axis, but we're only going to draw it to the right of x equals 1 because of this part of the piecewise function. So if I was to plug in x equals 1, I would get out y equals 5, so that shares the dot up here. Technically, I'd have an open circle, but the open circle is being filled in by this piece of the piecewise function. So if I plug in x equals 2, I get 5 halves. So 2.5 is where I should cross on the y-axis. So 2, 2.5, there's our next dot. And if I plug in, let's do something a little easier. If I plug in 5 in for x, I get out 1 for y. So here's 5 for x, 1 for y. So it's sloping down like this. There's a sketch of the graph. Then use the definition of a derivative to show that the function is not differentiable at x equals 1. As x approaches 1 from the left, the derivative is 5 because this slope, any tangent line you draw, is having a slope of 5. And you could just do it by taking a derivative. The derivative of 5x is just 5, right? And then as x approaches 1 from the right, that's using this part of the piecewise function. So if we take a derivative, here I haven't taken a derivative yet, that's the function. If I take a derivative, the negative 1 comes down, then it gets reduced by 1. And then I need to plug in 1 into that derivative. So this is negative 5 times 1 to the negative second, so that's negative 5. So negative 5 is the slope coming from the right. So the limits do not equal each other, right? So the derivative does not exist at x equals 1 because the two derivatives are not the same.